slide 2, and I'll share mine. Okay, so we're looking at slide 2, right? We know SOHCAHTOA. This is trig, so S is sine, C is cosine, and T is tangent. We should be starting to get pretty familiar with these patterns. When I have one side and one angle, I do the trig like we were doing yesterday, right? And my angle goes here next to the sine, the cosine, and the tangent. That's where the angle goes. Not to be confused, because there is a side that has X. Any questions about that? Do we know SOHCAHTOA? Okay. Yeah. So let's look at number 7. I'm going to try to put the chat back up here. I don't know where it went. Sometimes it hides. I don't know where it went. You guys are just going to have to unmute yourself today. I had the chat working in both my other classes, but it has evaporated. Oh, it's behind this screen. That's what happens when I have too many screens open. All right. So first thing we need to do is identify the O, the A, and the H. So what is the 11? Is that the O, the A, or the H? If it's opposite the 39. That is definitely the O. And then opposite the right angle is always the H, which leaves the X as the A. Okay. So I have information of the O, and I want information for the A. I don't have anything for the H, so I'm going to cross that off. Which one of my 3 functions works with O and A? TOA, absolutely. So we're going to use tangent. Tangent of 39 degrees. Remember, the angle always goes next to your trig function. Equals, and then we're going to make this into a fraction. So O over A. O is 11, and A is X. What special thing do I have to remember when I have a denominator that's a variable? What do I have to do? I do have to flip it. So I just trade the tangent of 39 for the X. X equals 11 divided by tangent of 39. And then you just open your Desmo, right? Or go to your calculator, whatever calculator you use. And 11 tangent 39 is already there for us from our last class. Do you have it in radians? No, radians would be 3.04. So if you got 3.04, you need to change it to degrees. But if you do tangent or 11 divided by tangent 39, you should get 13.6. So the directions do say round to the nearest tenth. So you want to keep that 0.6 and not round it to the 14. One of the reasons we use trig is to be more specific. It's like we were having trouble measuring things to the nearest tenth, especially if we're using inches, right? What about question 8? How do I start that? What do I have to do there? I do not have the opposite side. I do have the hypotenuse. Hypotenuse is over here. And I have the adjacent. Perfect. So what relates A and H? Yep, the C. So I'm going to do cosine. What do I write next? (46) cosine of the angle equals. And then how do I make my fraction? Is it x over 28 or 28 over x? x over 28. The hypotenuse always sinks to the bottom. So the hypotenuse is always in the denominator. Luckily here, I've got a number in the denominator. So instead of switching and dividing, I have to multiply. So x equals 28 times cosine 46. So what do we get when we do that in the calculator? That's what I got too. X equals 19.45. And because the hypotenuse is 28, that answer makes some sense, right? Should be smaller than 28 anyway. You don't. So here, all we're asking to do is find x. When we go to do the classwork today, I am going to have you find all three sides and all three angles. But usually you'll just be asked for one specific thing, which sometimes makes it easier and sometimes oddly makes it more difficult. So what about 9? Do I use sine, cosine, or tangent there? Does it have a hypotenuse? Or is it missing the hypotenuse? Yeah. So if it's missing the hypotenuse, I can't use that one. So I can't use sine or cosine. I've got to use tangent. And then how do I decide if it's x over 8 or 8 over x? Not always. So if I draw an arrow, just like I did from the hypotenuse and the right angle, if I draw an arrow from the 51, the side opposite that angle that I'm given is always the opposite. So it's always relative to that angle. And then the one that's right next door that requires like a curvy arrow, like a left turn arrow or a right turn arrow, that's the adjacent. The adjacent angle or the adjacent side makes the angle and the opposite side does not include the angle. So it's not always big and small. So I'm going to do tangent is O over A. So 8 over X. And what's the next step? Eight over tangent 51. Perfect. These two things swap places. So we go to our calculator, whatever calculator we're using. I got 6.52. Ariana, did you do 8 divided by tangent 51? So that opposite side has to stay on the top. Last one for our review on this topic. So do I use sine, cosine, or tangent here, and how do I know? I do not have the A, so I can't use cosine, and I can't use TOA, because that's the A, right? So I've got to do sine. And which one's the O and which one's the H? Mm-hmm. And do I multiply or do I flip and divide? Mm-hmm. That's what I got. How's everybody feeling about that? I'm only hearing a couple of people. We all good? If you have questions, add them to the chat. Thomas? Okay. So again, here we were given an angle and a side, so we use trig. And trig is the harder of the two because you've got to decide whether you've got a variable in the denominator and you have to divide, or whether you can just cross multiply. We shift gears a little bit with slide 3. With slide 3, we're given two sides. So like in problem 1, I had the 15 and the 4, or in the 24. Here, we're looking for an angle. So I've got to use the -1. I think of that as like the little degree symbol. I'm looking for the angle, so I have to use that -1. So it's still the O, the A, and the H. So am I going to use sine, cosine, or tangent for number 1? Is that the O or the A? That's the O. I can go straight through the middle of the triangle from the X to the 15. So that's the O. And this one is that's the hypotenuse. So which one has O and H in it? Sine. So we're going to do sine. I'm looking for an angle, so I got to put the little -1, the inverse, right? And then O over H, because we still just make that into a fraction, O over H. So 15 over 24. Remember from last week, I think it was, right? We still need to be in degree mode. You can go into functions and find your inverse sine. And then it was 15 over 28. No equal sign, no multiplying, no dividing. You just put it in parentheses. Did I do it right? Oh, it's 24. 15 and 24. 38.68. Sweet. So 38.7 degrees. And notice to the nearest tenth, that's going to be a whole lot more accurate than we can measure with a protractor, right? So that's the whole idea here, is we're trying to be super accurate. What would you do for number 2? We're going to do cosine. Why are we going to do cosine? What's the 11? Excellent. So we're going to do cosine. Again, I'm looking for the angle, so I got to put that -1, that inverse. And then if I don't remember, so TOA, the A and the H are my fraction. So the A is the 8 and the 11 is the H. And then what do you get when you put that in your calculator? If you haven't already gone on to 3 and 4, try 3 and 4. Label your O, your A, and your H. And then figure out which function you're going to use. And then check them in your calculator. And when you get your answers, let me know what they are so we can check them. Nice. And if you're getting some weird decimals, let us know what decimals you're getting so we can try to figure out how to help. Because there's a lot of different little places to make mistakes here. Anybody got question 4? Did you put inverse tangent 20 over 37? So if I put it in, are you using Desmos? What'd you do wrong? And that's definitely a hazard of programming. You got to make sure you're programming correctly. Anybody else get 38.5 for number 4? Awesome. Any questions on those? So I'm going to go back out to fit the screen. My writing is going to go crazy, but just allow that to be weird graffiti. So just again, if you're given a side and an angle, right, you're going to use trig. Side and an angle, use trig to find the other side. If you're given 2 sides, you can use inverse trig to find an angle. Okay. The whole rest of these, 4 through 13, are going to give you triangles in some kind of sports field, and you need to fill out all 6 angles and all 6 sides, or all 3 angles and all 3 sides. So what do I know here? We'll do the first couple together just to make sure we understand what we're doing. What can I already fill in that's given to me? Side AB is 90 feet, so you can definitely type in or write in 90 feet. And side BC, also 90 feet. Easy peasy. Am I given anything else? There is a right angle at B. So what's the measure of angle B? 90 degrees, right? Okay. So do we want to find angles first or sides first? What do you think? We can do angles. So we're looking for angle A and angle C. They are definitely going to be acute angles for sure. What else do you know about those angles? They're going to be acute. They are physically small, so they're going to be less than 90 degrees. What else do you know? They are going to be equivalent. So what kind of triangle is this pink triangle with 2 sides of 90 degrees? It is isosceles. So if it's an isosceles triangle, it has 2 congruent sides and it has 2 congruent angles. That does mean they're 45 degrees. How do you know they're 45 degrees? because the other one is 90. So if I know the whole triangle is 180 and I know angle B is 90, that means angle A plus angle C has to equal 90. And Elif said these are both the same, so I can just divide by 2, which means both of them are 45. That only works in isosceles triangles. Okay, isosceles right triangles are always going to be 45, 45, 90. So how do I find AC? This is my last problem. Hey, Pythagorean Theorem, a squared plus b squared equals c squared. What are my a and my b? Are they 45 and 90? Why 90 and 90? So the A and the B and the C are always sides. So Pythagorean theorem works here for your sides. So what is 90 squared plus 90 squared? And then take the square root. I like it. Beautiful. So I'd like to do one more together, and then you guys will have the choice of working on your own or working in breakout rooms, or we can stay working whole class. Doesn't really matter to me which way we do it. Last class wanted to do breakout rooms, but you guys can choose. So how would we start with this one? What do we know? What's given to us? I heard AC is 30 and CB is 60, all at the same time. What else do I know? Angle C is a right angle. And in all of these, you're going to have a right angle somewhere. The trick is to find it. Oh, not 90 feet, 90 degrees. So now what? We do have to find angle A and B. I heard you say A first, so let's put an X there. How can I find an angle if I know two sides? I could do 180 minus that angle. So if I do 180 minus, I don't know, angle A. Is it? So in the triangle that we had before, both of those angles were the same because the sides opposite them were the same. This is not an isosceles triangle. This is a scalene triangle where all the sides are going to be different. So that's not going to work. We can't divide by 2. What do we do on slide 3? We can use tangent. So this is the O and this is the A. Do we want to use tangent or inverse tangent if we're looking for the angle? That little -1, right? So we're looking for the degree, so we got to use the inverse tangent. And then is it 60 over 30 or 30 over 60? TOA. OA. So 60 over 30. What is the tangent of, or inverse tangent of 60 over 30? What is it? 63.4 degrees. So angle A is 63.4 degrees. Now, how can I find angle B? Can I subtract? What do I subtract from? 180. So if we do for 180, I have to subtract the 90 at C and then subtract the 63.4 from A. And so what do we get for angle B? And notice that these two acute angles are always going to add up to 90 degrees. So now we've got one piece of information left to find. What's the last piece of information we need? The hypotenuse. How do I find the hypotenuse if I know two sides?
30 squared and
so remember, my A, my B, and my C are always sides. So once you do 30 squared and add 60 squared and take the square root, what's C equal? It kind of makes sense. So on each one of these slides, you're going to use Pythagorean Theorem once. You're going to use triangle sum once. And you're going to use some kind of trig function once. And that's how you're going to get all your information. And you don't always have to use tangent, but you do always have to use some kind of inverse trig function. Next question is, do you want to keep doing this together? Do you want to work in breakout rooms or do you want to work alone? Together?
yeah.
Okay. I love that this class just wants to work together. Let's look what's next. Gymnastics, okay? What do I know about the gymnastics floor? A and B is 40. C and B is 40. B is 90 degrees. So what should we do first? We should find the angles. Okay, how are we going to find the angles? It is an isosceles triangle, so it's definitely isosceles. It is. Okay, that was easy. Bryce, there is a pair deck that you are welcome to use, or you can go to today's assignment and work on the Google Slides that we're working on. We're just practicing Pythagorean Theorem, all the stuff we know about triangles and trig. So I heard somebody say something about A's, B's, and C's. Are those lowercase a, B's, and C's for sides, or are they uppercase a, B's, and C's for angles? Pythagorean Theorem is always lowercase. Seems like a weird detail, but it is a detail. So how is that helpful? What do I have to use in there? What am I finding? What am I using Pythagorean Theorem to find? The hypotenuse. So what do I have to substitute into that Pythagorean Theorem? So then you're going to do 40 squared, which is 1600, and 40 squared, which is 1600. Then you're going to add those two up. So 3200. And then what's the last step? Find the square root. Perfect. And if you're still unsure about this, that's why we're working together. So just make sure you're writing down everything that we're writing until it clicks with you. And ask questions. Say it again. 56.7, and that's feet, right? If you know what you're doing and you want to work ahead, you are 100% welcome to work ahead too. Everybody got slide 6? Okay. Hockey rink. I don't know why I put hockey court. It's a hockey rink. So what can I label here? AB. So AB is 85. BC is 200. And angle B is for sure the 90 degrees. So what do I want to do first? We can. How do I find the side? So I've got A squared, B squared, and C squared. So that sounds like it's just a difference of rounding, right? Yeah. Yeah. So 217.3. C equals 217.3. And that makes sense because that should be the longest side, so it should be the biggest number. It is a big number. My son used to play hockey. One of the best memories of him playing hockey is there was this really horrible team up in Maryland that was being super disrespectful to a couple of his teammates. And a couple of them got into like a fist fight on the ice. My son, who now is 6'4" and 230 pounds of very lean muscle, skated up, did like that whole like skate stop where like ice sprays everywhere, picked up the guy who was beating up on his teammate and just like moved him off ice. It was hilarious. Yeah. I was like, you go, Mackenzie. You protect your teammate. So that's my little story. So now how do I find the angles? Which angle do I want to find first? Angle A or angle C? C, okay. So I'm going to put an X there. Do I want to use sine, cosine, or tangent? We can. Because we just found this third side, we have all three sides. We can use any of them. But tangent does work out nicely because we're given those and they're nice round numbers with no decimals, right? So if I use tangent, I'm looking for an angle, so I got to use the inverse. Which number do I put in the numerator and which number do I put in the denominator? So if I go through the triangle to the opposite side from the X, that 85 is the O, and the 200 is the A. So we're going to do TOA is O over A, so 85 over 200. And when you do that, how many degrees is X? Perfect. So if X is 23 degrees, how do I find angle A? You can subtract, absolutely. Do I subtract from 180 or from 90? Okay. So 180 minus the two angles that I know. So 77 or 67? You gotta like uncarry the 1 when you're subtracting. I don't know how to say that better. Nice. So what's after a hockey rink? Football field. So AC is 160. 300. Okay. So we can definitely find that third side. I think that makes perfect sense because it should be bigger than 300, right? So that's one of our Pythagorean triples, right? And they do happen every once in a while. So now do we want to find A or find B first? Okay. So we're going to put our X here. That means if I go through the triangle, is the 300 the O or the A? Which means this side is the A and this one's the hypotenuse. So do we want to use sine, cosine, or tangent? We can use sine. So we know that this hypotenuse, that was AB, that's 340. So if I use sine, I want to use O and H. Hypotenuse is always on the bottom, and you can always remember that's why we start this with SOHCAHTOA, right? So sine opposite over hypotenuse. So what'd you get for an angle when you did that? 61.9. And that makes sense because it's opposite the 300, which is the biggest side. Well, it's the biggest leg. So that 61.9 makes perfect sense. 61. You can, yeah. 62 degrees. That's a 9, by the way, even though it doesn't look like a 9. So then if I know this is 61.9 and I know angle C is a 90-degree angle, A plus B should equal 90 degrees, right? So you can do the whole triangle, 180 minus 90 minus 61 or 62, or you can just do 90 minus 62, which gives us 28. Boom. Doesn't it make you feel so smart though? Oh my gosh, it should make you feel so smart. It's like lifting weights or running. It's building your brain muscle. Although my daughter told me the other day, Mom, your brain is not a muscle. I don't know why you keep saying that. We are almost done though. We only have 4 more to do. My oldest son used to just want like a microchip. Just put a smart microchip in my head and let me be done with school. He was so desperate to leave school. Not killing your brains. I'm working them out. So what do I do with the soccer field? Where are we going to start? This side, okay. So AC is, oop, I need a pen. AC is 180. And BC is 300. What'd you get for AB? 349.8. Sure.
Yeah, totally.
And then what angle do I know? And do we want to look for A or B? So do we want to use sine, cosine, or tangent?
Cosine.
Okay. So we haven't used cosine yet. So we need the adjacent. And we need the hypotenuse. We're looking for an angle. And we're going to do A over H because the H always sinks to the bottom.
Okay.
30.9. I think that sounds like a great answer. Do we want to round that?
Yeah.
So if X is 31 degrees, angle B is 31 degrees, what's angle A? 60 or 59?
59. Oh, I did the wrong number.
Okay.
Yeah, 59.
59. Because those are two acute angles in the right triangle are always going to add up to 90 degrees. Uh-oh.
Did your screen go gray? Yeah. You might have to leave and come back.
I'll try to post a video of it too, Sterling. But if you want to leave and come back, I'll let you back in. So after the soccer field is basketball court.
There's so many of these. They never stop.
They do. They stop at 13. My brother gave me one of his old phones a couple months ago, and I had forgotten what it was like to have a nice phone. I'm with you. Can you read that? Correct. You're welcome. So what are we going to do for the basketball court? I do 100% know how good it is. And if you had to use the computer that the school issued me, you would feel even more blessed. I know. I'm in the process of trying to write a grant for us to get touchscreens for Kempsville. So I'll show you when we get to lunchtime, like when we're done. I made a whole slide that's animated. It's so cool. I made a Google form. I made my own PayPal account so people who weren't in the building could still pay, and we could like mail them shirts. They told me I can't use the PayPal account. I was like, well, how can I collect money then? Well, you have to collect it face to face. I'm like, what? Or they're like, well, there are these like 5 vendors you can go through, but then you only earn like 10% of the t-shirt sale. Yeah. I'm like, oh no, we're trying to make at least 50%. Mm-hmm. Right. Right. Venmo is free, and so is Zelle. Yeah. So if you run, it's free to transfer money with both Venmo and Zelle, but they wouldn't let me do that either. Yeah. That's a new rule. My kids had them when they were in high school. Yeah, I'm with you. Mm-hmm. I'm with you. I feel like if you're old enough to have a job, you should be old enough to have a credit card and start building credit.
I think for this one, I did tangent,
Okay.
which is in 60 over 106.5, right?
If we're doing tangent, we need opposite and adjacent. So we need the 2 legs.
I did the hypotenuse.
We also need to know which angle we're going from. So are we going from A or from B? Okay. So if we're going from A, then this is the O, and this is the A, and this is the H. So if we're going to do tangent from X, we've got to do 94 over 50. 94 over 50. Notice that the 94 is the bigger number and it's on the top. So sometimes the bigger number is going to be on the top. You can't just always assume that the bigger number goes to the bottom. Okay. You got. So inverse tangent 94 divided by 50. Yeah, 61.99 or 62. And that was angle which? A or B? Which means angle B is? Awesome. We're getting close to done. Swimming pool? What do we know about the swimming pool? Is an isosceles triangle? So sometimes because this perspective is weird, I redraw it. I've got 50 and 100. A has the little square. So that question mark is the hypotenuse. That's the C. Mm-hmm. So how do I find the hypotenuse?
50 squared plus 103.
Mm-hmm. $111.8. Okay. And so do we want to find B or C first? Okay. So we want to use sine. Okay. If we use sine, is the 50 the O, the A, or the H?
That's the
That's the O. And then what goes in the bottom of our fraction in the denominator? The hypotenuse, which is
111.8.
and that was angle, and we said 63.4. Okay. Which angle did you go from? Did you go from angle B? Yeah, let's check. Because that's our other angle. So my guess is 0.8. Yep. So sine of this is going to give us 26.6. So angle C is 26.6. You found the other angle. 26.6. And then the other angle is B, which is whatever the other one was, 63.4. So you got to be super careful. You have a whole bunch of choices here, right? You can do sine, cosine, or tangent from either of those two angles. So there are 6 different trig functions you could do to get those angles.
My mom would call me.
Back to slide 10.
I don't like how slide 12 is looking right.
I was so excited to learn about a speed climbing wall last week that I had to add one in. So on slide 12, we're looking at the blue triangle only. You can square a decimal, absolutely. It is not mission impossible. So we're going to do the exact same thing. AC is 16.7 meters. And BC is 3 meters. Those are the 2 legs. So C is my right angle. So how do I find AB?
Okay, so I got 336 and I squared it and I got 16.96.
Did you square it or square? Oh, 16.96. Yes. So C equals 16.96. Did anybody else get that? So let's round that up to 17. And then do we want to find angle A or angle B? Okay. And do we want to use sine, cosine, or tangent? Okay. So we'll use cosine. We need adjacent and hypotenuse. What's the adjacent? The 3. So the adjacent is here. And what's the hypotenuse? 17. That's the H. So we're going to do cosine, inverse. And then A over H, so 3 over 17. 79.8. And that really does make sense because 16.7 is so much bigger than 3, right? The opposite side should be really big because that's the obtuse or the really big angle. So what's angle A? This little skinny thing up here. So when you're climbing a rock climbing wall, you've got a really long, narrow thing that you're climbing up. Are you so excited? So now we've got this little green sliver of a triangle. So one of the things that makes rock climbing walls really hard is they're not flat against the wall. They're like tilted out a little bit. So you're climbing a little bit upside down. And fun fact, they used to build castles like this back in like the Middle Ages, because then it was harder for people to climb up the walls. And if they wanted to throw hot tar or anything crazy on people that were trying to climb up, it would go down and hit them in the head. Wouldn't that be cool? I think it'd be awfully cold myself. So we know the 16.7 and we know the 17. How do we find AC? We are definitely finding the side because we know angle A up here is our right angle. So I think we want to start with the hypotenuse and we want to do C squared minus A squared equals B squared. So 17 squared minus 16.7 squared equals B squared. And it should be really tiny. Say it again, what you got? $17 squared minus 16.7 squared. 10.11. And then what's the last thing you have to do? Are we done here? So B squared equals 10.11. What's the last step in Pythagorean theorem? You have to square root it for sure. So it's not quite small enough yet. What's the square root of 10? It is. We can do tangent. Am I finding C or B? We said B? Okay. So tangent. Because that's O and A. And those are both degrees, right? Nice. Oh, it is 79.2. I was so excited to be done. I wasn't even double checking. Thanks, Sterling. That is it. You can leave now. So I'll see you guys tomorrow. Bye. We're going to do special right triangles tomorrow. So we're going to do a similar thing. We're just going to kick it up a notch. Friday. So if you wanted to start watching videos to figure out how you're going to build your catapult, that'd be fantastic. You do. You should get it out and make a video for us. I would like for you to build a new one, but you absolutely can use that one too. How big is it? Like, how far will it fling stuff? Oh. You should take it outside and make a video to see how far you can fling it. Yeah. That's what we would do. If we were in school all together, we would be out on the football field or maybe out in the parking lot, depending on how many cars were in the parking lot. But definitely out on the football field testing them to see who's can fling the farthest. Cool. Make sure you ask your parents' permission. Don't get in trouble because of me. Okay. Okay. Sweet. I like your parents already. I'll see you later, Elias. I did. You inspired me. See ya.